Hello children, welcome to my Masters Academy. In this class we shall go for logarithms. Till now we have discussed about Euclid's division algorithm, rational numbers and their decimal expansions, prime factorization and irrational numbers. In this class we shall go for logarithms. This is the first time we are encountering this word logarithms. What do you mean by logarithms? If you are given say x plus 2 is equals to 0, we can find out the value of x. X is equals to minus 2. That means whenever you are getting x in the equation, you can find the value of that variable directly. If it comes in exponential form, suppose say a power x is equals to 2. A power x is equals to 2. Then how can you find the value of x? How can we find the value of x? Then we can say the value of x is logarithm of 2 to the base a. That can be read as log 2 to the base a. This is how we can find the value of x if we get the variable in the exponent. This means if we have variable in the exponent, then we encounter the term called logarithm. Now we can say if a power x is equals to n, then x is equals to log n to the base a. Log n to the base a, and n should be always positive and it should be greater than 0 always. That means it should not be equal to 0. It should not be equal to 0. And this is also a should be greater than 0 and a should not be equals to 1 and n should be greater than 0 and n can be any real numbers. N can be any real numbers. A and n can be any. These are the four conditions we need to remember. A should be always greater than 0 and a should not be equal to 1. That means you can encounter 0.0001, 0.00002. That can be, a can be like this. And a should not be equal to 1. Other than 1 and greater than 0, it can be any value. That means it should be positive but it should not be equal to 1. A should not be equal to 1. And n, where we got n here, that is logarithm of n should be greater than 0. That means that should not be equal to 0 also. We can't find the value of 0. Log 0 can't be defined. Can't be defined. This you have to remember. Log 0 can't be defined and a n should be real numbers. A n should be real numbers. That can be any real numbers and they should follow these rules. A is greater than 0, a is not equals to 1, n is greater than 0, a n should be belongs to real numbers. This is logarithm. Logarithm of a number can be defined when we encounter the variable in the exponent. When we encounter variable in the exponent. Now suppose if it is a power 0 is equals to 1, we know that. By exponents and powers, we know that a power 0 is equals to 1. By using this formula, we shall see what would be the value of log 1. We know a power, that means anything power 0 is 1. I said if a power x is equals to n, then x is equals to log n to the base a. A power x is equals to n, then x is equals to log n to the base a. Here you have a in place of a and 0 in place of x and 1 in place of n. Already I told you n should be greater than 0, so n can be 1. Now apply that here, that is a is equals to a, x is equals 0, n is equals to 1. Then you can say x is equals 0 log n is 1 to the base. That means log 1 to any base will be 0. This is what we can derive. Log 1 is 0. Log 1 is 0. If you don't write base also, there won't be any problem, because whenever you don't have a base, you consider the base as 10 as we follow decimal system. Deci means 10. We follow decimal system. So if there is no base for given logarithm, then the base should be considered as 10. Now let us go for a power 1 is equals to a. That is, if the base and the number are same. That means, say we know a power 1 is equals to a, then a is equals to a we have, x is equals to 1 we have, and n is equals to a we have. So if you substitute that here, that is x is equals to log n to the base a. What is x we have? 1 is equals to log. What is n we have? A. What is a? We have a. So log anything to the same base. If the logarithm of two numbers, that means logarithm of the number of the same base is 1. Log a to the base a is 1. That means if you get log 2 to the base 2, that will be 1. Log 3 to the base 3, that is 1. Log 1 to the base 4, that is 0. Here we got that. So log 1 is 0. Log of the number to the same base is 1. This both we have to remember. So this is how we can find out logarithms, and we can find out the value of variable if we encounter the variable in the exponent. Suppose if the question is given 3 power x is equals to 5. Find x if 3 power x is equals to 5. Then we know that a power x is equals to n implies x is equals to log n to the base a. So we can write down that as x is equals to log 5 to the base 3. Just we need to apply the formula. A power x is equals to n implies x is equals to log n to the base a. That's what we have applied here. So next, if the question is, let me take a question from the textbook. Determine the following log 5 to the base 25. If the question is given in this form, log 5 to the base 25, then we need to find out this value, a power x. How we can find out? Let us consider this as x. Let us consider this as x. That means if you find the value of x, that will be the value of log 5 to the base 25. Now that can be written as 25 power x is equals to 5. Why? Because here we have n is equals to 5, a is equals to 25, x is equals to x. If log n to the base a is equals to x, then that implies n is equals to a power x. What is n we have? 5. Sorry. N is equals to, n is equals to 5. So n is equals to 5, and a we have 25 power x. 25 power x is equals to 5. Now we need to equate the bases in order to get the value of x, because we know that a power m is equals to a power n implies m is equals to n. That means if the bases are equal, then the powers are equal. We have learned this in exponents and powers in our earlier classes. So what is 25 can be written as 5 power 2 whole power x is equals to 5 power 1. This is in the form of a power m whole power n, that is a power m into n, that is 5 power 2 x is equals to 5 power 1. Now we got this in the form of a power m is equals to a power n. Then we can write m is equals to n, that is 2x is equals to 1, then x is equals to 1 by 2. What is x we have? Log 5 to the base 25. Log 5 to the base 25 is 1 by 2. This is how we can find out the value of given logarithm by applying the formula a power x is equals to n implies x is equals to log n to the base a. Let us go for one more problem so that it will be easy for you to understand. For solving the problems in logarithms, we need to have a good command on exponents and powers. That is, a power 0 is equals to 1, a power 1 is equals to a, a power m into a power n is equals to a power m plus n, a power m by a power n is equals to a power m minus n, a power m is equals to a power n implies m is equals to n, a power m by a power n is equals to a power m minus n. All these formulas we need to know to solve the problems of logarithms. Next, we shall go for one more problem. As I said you, this can be log 3 to the base 81. Now, let us take this as x. Let us take this as x. Now, this is in the form of log n to the base a is equals to x. That implies a power x is equals to n. Now, what is in place of a? 81. So, 81 power x is equals to n is 3. Now, 81 can be written as 3 power 4 because by prime factorization 3 27s, 3 9s, 3 3s. So 3 power 4 whole power x is equals to 3 power 1. Again this is in the form of a power m whole power n, that is a power m into n. A power m whole power n is a power m into n. Apply that here. Then you will get 3 power 4x is equals to 3 power 1. That will be 4x is equals to 1. That implies x is equals to 1 by 4. This is how we we can find the value of log 3 to the base 81. Now I hope you understood how to solve the problem when we have x in the exponent, x in the power side. Now let us go for properties of logarithms. I will explain one property of logarithm today, and tomorrow we shall go for, and in the next class we shall go for another property of logarithm. Today we are going for product rule of logarithm. What is product rule? Product means if you have two variables, say x and y, two distinct variables with base a, then you can write this as log x to the base a plus log y to the base a. Log xy to the base a is equals log x to the a plus log x to the base a plus log y to the base a. Now, how can we derive this? By using the formula a power m into n is equals to a power m plus. Let us see that. Let us take m is equals to log x to the base a. That implies x is equals to a power. Next, n is equals to log y to the base a. That implies y is equals to a power n. X is equals to a power m and y is equals to a power n. And m is equals to log x to the base a, n is equals to log y to the base a. Now let us go for this. Let me erase this. We have RHS as log x to the base a plus log y to the base a. But what is log x to the base a? M. Plus what is log y to the base a? M. That means m plus m. And RHS, in LHS we have log xy to the base a. xy. What is x into y? X into y is a power m into a power n to the base a. But what is a power m into a power n? A power m plus n to the base. Now this can be taken to the coefficient of logarithm, that is m plus n into log a to the base a, because log x to the power of m to the base a is equals to m into log x to the base a. This is one more formula you need to remember. Log x power m to the base a is equals to m into log x to the base a. That means if you have a power to the variable of the log, then the power comes to coefficient m into log x to the base a. M into log x to the base a. So what is log a to the base a? We have 1. Log a to the base a is 1. Substitute that. So m plus n into 1 is m plus n. But what is m plus n? We got log x to the base a plus log y to the base a. That means these both are equal. Log xy to the base a is equals to log x to the base a plus log y to the base a. This is product rule of logarithm. Tomorrow we shall go for quotient rule of logarithm. That is log x by y to the base a is equals to log x to the base a minus log y to the base a. With this I am concluding the class. I hope everyone have understood this class. If you have any doubts, you can keep that in the comment or chat box so that I can clarify your doubts. In the next class, we shall go for quotient rule of logarithms. Bye everyone.